In this unit, we're going to speak about microwave links. A microwave link is a communication system that uses a beam of radio waves in the microwave frequency range to transmit information between two fixed locations on the Earth. They are crucial to many forms of communications and impact a broad range of industries. For example, broadcasters use microwave links to send programs from the studio to the transmitter location, or from the mobile units to the studio. And in both cases, they can be miles away. For example, microwave links carry the cellular telephone calls between the different cell sites and connect these different towers with the fixed network. Wireless internet service also use microwave links sometimes to provide their clients with high-speed internet access without the need of cable connections. And telephone companies still transmit calls between switching centers over microwave links, even as a lot of them are being replaced by fiber optic cables. Microwave links are also used by companies and government agencies to provide communication networks between distributed facilities, for example, between the several buildings of a company within a city. One of the reasons why microwave links are being used is that they are broadband. That means that they can move large amounts of information at high speeds. Another important quality of microwave links is that they require no equipment or facilities between the two terminal points. So installing a microwave link is often faster and it's always faster and less costly than a cable connection. Finally, they can be used almost anywhere as long as the distance to be covered is within the operating range and there is a clear path. There are no solid obstacles between the two transmitting antennas. And as microwaves are also able to penetrate rain, fog and snow to a certain extent, they are not disrupted in case of bad weather in most of the cases. And if the conditions are very, very hard, they can be disrupted, but it's not what happens mostly. Their main drawback is something I've said, is that other radio communication frequencies can go over obstacles, but microwaves need line of sight between transmitter and receiver antenna to work properly. A simple one-way microwave link includes four major elements that are found in every radio communication system, including cellular telephones, two-way radios, wireless networks, or commercial broadcasting networks. These four elements are transmitter, receiver, transmission lines, and antennas. These are the same components, but the technology used in microwave links differs quite markedly from that used at lower frequencies. A lower frequency means longer wavelengths. Why? Because techniques and components that work well at low frequencies are not usable at the higher frequencies used in microwave links. Higher frequencies mean shorter wavelengths, and this has an influence in the physical components. For example, ordinary wires and cables that are used for lower frequencies function poorly as conductors of microwave signals. And on the other hand, microwave frequencies allow engineers to take advantage of certain principles that are impractical to apply at lower frequencies, because, for example, the size of an antenna depends on the frequency it is used. At higher frequencies, smaller antennas. So they can, for example, with microwave systems, we can use parabolic or dish antennas that can focus a very narrow microwave radio beam that with lower frequencies would be so big that would be impractical or uneconomical for most purposes. In a microwave link, the transmitter produces a microwave signal that carries the information to be communicated. That information, that's called the input, can be anything that can be sent by electronic means, for example, telephonic calls, television, as you can see here, television or radio programs, text, moving or still images, web pages, or a multimedia combination of all of them. The transmitter has two fundamental jobs. One is generating the microwave energy at the required frequency with the desired power level, and the other one is modulating it with the input signal so that it conveys meaningful information. This modulation is accomplished by varying some characteristics of the energy in response to the transmitter input. For example, a flashing light to transmit a message in Morse code can be an example of modulation, because the differing length of the flashes for dots and dashes and the intervals of darkness between them convey the information, in this case of a test message that is modulated over the light. The transmission line, carries the signal from the transmitter to the antenna, and at the receiving end from the antenna to the receiver. In electrical engineering, a transmission line is anything that conducts current from one point to another, for example, a lamp cord, power lines, telephone wires, or speaker cables. But at microwave frequencies, those media have excessive signal losses. In their place, engineers use coaxial cables or especially hollow pipes that are called waveguides. On the transmitting end, the antenna emits the microwave signal from the transmission line into the free space. And free space is the electrical engineer's term for the emptiness or void between transmitting and receiving antenna. And it's not the same as the atmosphere, because really the atmosphere is not necessary for any type of radio transmission. The air is not necessary. That's why in outer space we can communicate with space vehicles. At the receiving side, an antenna pointed towards the transmitting station collects the signal energy and feeds it into the transmission line for processing by the receiver. Antennas used in microwave links are highly directional, which means they tightly focus the transmit energy and receive the energy mainly from only one specific direction. This contrasts with antennas used in other communication systems as broadcasting, that are they are broadcast in all directions. They are omnidirectional, or at least in more than one direction. By directing this transmitted energy towards where it's needed and concentrating the reception point, the microwave antennas can cover long distances using a small amount of energy. And other thing that is very important is that they can interfere they can have very low interference with other links.